All right, so this is going to be a video about deriving the derivative formula for exponential and logarithmic functions. Okay, so basically what I'm going to be doing is finding the derivative of this f of x right here where it says a to the x. And to do that, we're going to be using the limit definition of derivatives, which is right here. Once we find the derivative of that a to the x, that exponential function, we're going to use that to find the derivative of the logarithmic function. It is important to note that exponential functions and logarithmic functions are inverses of each other, which means they're opposites. So it's kind of like addition and subtraction, they're opposites of each other. Multiplication, division, they're opposites of each other. Exponential and logarithmic, they are inverses of each other because they're opposites of each other. All right, so to find this derivative, I am going to use this limit definition of derivatives like I already said. But first thing I'm going to do is find this f of x plus h here, if based on the fact that this f of x right here is equal to a to the x. Now that I have my f of x plus h, I can put that in for this right here, and we can use the limit definition of derivatives to try to find the derivative of this a to the x. So here we go. First thing I'm going to do is substitute everything in that I know. So this f prime of x is basically just going to be the derivative of a to the x. I'm just going to kind of rewrite that. So it's f prime. Remember, prime means the derivative of whatever's in front of it. So it's the derivative of f of x. F of x right here is a to the x. This is our derivative operator. It's the derivative of a to the x. It means to take the derivative of whatever's after it. We want to take the derivative of this a to the x. Okay, this is going to be equal to, as h goes to 0, f of x plus h is this a to the x plus h right here. So I'm going to write a to the x plus h minus a to the x, and it's going to be minus a to the x because that's our f of x right here, as it's defined right here, f of x. Okay, and then I'm going to divide all of this by h. So whenever you have an exponent that's a to some addition up here, so it's x plus h right here, you can rewrite it as follows. So you can rewrite it as a to the x times a to the h minus a to the x all over h. So basically I just rewrote this part right here. That's basically the big change from this orange to the green. So now what I'm going to do is I'm going to factor out this a to the x because there's an a to the x here and an a to the x here. Okay, so I factored out the a to the x. So there's an a to the x here and a to the x here. I factored it out, so I put that common factor in front right here, and you end up with something like this. Now it is important to note that this a to the x right here is completely independent of this limit as h goes to 0 because there is no actual h in it. So what I can do to this a to the x is I can actually drag this out and put it in front of this limit as h goes to 0. So I'm going to do that real quick. Okay, so again, basically all I did was move this a to the x from this blue to this darker blue right here. That's all I did, is just put it in front. Now, this part right here, this a to the h minus 1 over h after the limit, so the limit as h goes to 0 of a to the h minus 1 over h, this part right here actually has a very specific value. It actually defines our natural logarithmic function. Okay, this whole thing that I just circled right there is actually going to be equal to ln, so the natural log of whatever this variable is right here, which is a. So that's actually going to be equal to ln of a. And we're going to talk more about this in class of where this ln a comes from. But just for now, just for this derivation, just know that what I circled right there, what I circled right here, is just equal to ln a. So that means that this last step is going to simplify to a to the x times ln a, like this. Okay, so that means I'm going to bring down this derivative of a to the x. This basically means that the derivative of a to the x is equal to a to the x, so it's kind of like duplicating itself here, times ln a. So there is our formula for the derivative of the of an exponential function. So right there is our equation for the derivative of an exponential function, and we're going to be using that extensively in this class. Knowing this fact right here, what we ended with this purple right here, we're going to use that to figure out the derivative of our logarithmic function. We're also going to be using some implicit differentiation. So if you don't understand implicit differentiation, you might want to learn that first before going on with the rest of this video. All right, so the next part of this video, we are going to be finding the derivative of a logarithmic function. So I'm going to write y equals log base a, so it's just any base you want, of x. Okay, so we want to try to find the derivative of y. So basically, I'm going to write that off to the side just so we kind of know what we're looking for here. We are looking for the derivative of y. So dy over dx equals question mark. That's the whole goal of this. Just like before, we were trying to find the derivative of the exponential function. Now we're trying to find the derivative of this logarithmic function right here. So dy over dx is what we're looking for. Now to do this, I am going to actually, knowing that exponentials and logarithms are inverses, I'm going to kind of use that to my advantage. Because I know the derivative of this exponential, I'm going to turn this basically into an exponential. Now to do that, what I'm going to do is do a base a on both sides here. So I'm going to do base a to the y power, and then I'm going to do the exact same thing to the other side, base a to the log base a of x power. Okay, so I basically based a both sides. Remember, what you do to one side, you equally have to do the other, so that's what I basically did here. Now, a really cool thing happens while doing this is that this a to the y stays the same, but over here, log base a and base a are going to cancel because they're inverses of each other, and you're just going to have an x here. So now we have an exponential function right here, and we're going to use the fact that we know the derivative of exponential functions based on this purple right here, this formula that we just figured out, we're to try to solve for that dy over dx. Okay, you should notice that this is kind of going to be like an implicit differentiation problem, and we're going to solve it in a similar way that we do implicit differentiation problems. So the first thing I'm going to do is take the derivative of both sides with respect to x, and the reason for that is because we are trying to find this dy over dx. So I'm going to take the derivative of this side, a to the y, and I'm going to take the derivative of this side, which is just x. Okay, the derivative of a to the y, okay, if you remember from implicit differentiation rules, the y and the x don't match. So what you're going to need to do is take the derivative as normal. So the derivative as normal would be a to the y times ln a. Okay, that's going to be based on this purple down here, this formula right here, for the derivative of an exponential function. Okay, but now since that y and that x don't match, you do have to remember to multiply, let's put this in parentheses, you do have to multiply by dy over dx. Okay, and this is going to be equal to the derivative of x. The derivative of x is 1 using the power rule. Okay, if you remember, our whole goal here is to figure this out right here. We're trying to find what dy over dx is. So we're trying to solve for this. Okay, in order to solve for that, we need to get rid of this a to the y and this ln a. So we're going to divide both sides by a to the y times ln a. Okay, I'm going to divide this side by a to the y ln a. Okay, so this is going to cancel, that's going to cancel. So now you have the dy over dx is equal to 1 over a to the y ln a. Now what's great about this a to the y right here is it actually, this a to the y right here, it actually simplifies to x, because if you see this line right here, a to the y is equal to x. So what I'm going to do is write dy over dx is equal to 1 over, now again this circled part right here is just equal to x, so I'm just going to write 1 over x ln a. Alright, so this dy over dx is equal to 1 over x ln a. Well, dy over dx is the derivative of y. In this case, our y is log base a of x. So what we can do is, I'm just going to write this kind of in front of it here, is the derivative of log base a of x is equal to this 1 over x ln a. So now I have my formulas for the derivative of exponential functions. I have my formulas for the derivative of logarithmic functions, and that's basically what I was setting out to do in this video, was just basically deriving those two formulas. So if you have any questions about anything in this video, let me know.